welcome to today's event. I am Gemma Monk-Hartley from Herefordshire Green Network's Building Sense Group, which is an initiative that was started in 2020 to bring together people, information and professional expertise to help with the challenge of making homes comfortable year-round in the face of both high heating bills and, of course, cutting carbon emissions. Today, we're delighted to be able to host this webinar on behalf of the Future Ready Homes programme, of which HGN are project partners, and with the support of the Green Register, who since the year 2000 has trained thousands of construction professionals from all disciplines of the industry to build better, more sustainable buildings. A tiny bit about Future Ready Homes for those that don't know what it is. It's been running in Shropshire, Powys and Herefordshire since early 2022 and being delivered by Marches and 7Y energy agencies with the support of groups such as ourselves, HGN in Herefordshire, Lightfoot in Powys and Zero Carbon Shropshire in Shropshire. The main focus of the programme has been to promote and support good practice energy retrofit across homes in the Marches area. And doing that through webinar series, why we're here today, retrofit advice, fully funded home retrofit surveys and plans, which unfortunately have now all been snaffled, and events like Green Doors, which has just concluded. On that note of fully funded home retrofit surveys, though, I will just add in now, if you're in Gloucestershire, which I believe there might be a few of you, I think through 7Y Energy Agency, there are some fully funded home surveys around. So I will forward you details about that, but I just wanted to pop that in there now. So yeah, I'd also like to take the opportunity to thank all of you that have given feedback to us on our past webinar series and on your retrofit experiences to date. It's really, really appreciated and it is very valuable to us right now. Future Ready Homes is due to conclude at the end of January. But we are applying for more funding to see if we can continue for another 2 years. So yes, your feedback is really, really important to those applications. So that all aside, I can now introduce our webinar and speakers. Today we've got ecological design and build company Hawkland returning to us after their much acclaimed initial webinar on how to retrofit the traditional terraced home a few weeks ago. Today we have Ben Nother, not Anne, Anna, as some of you might have been expecting. And he is here to talk to us all about how to insulate those tricky but essential areas over our heads: flat roofs, sloping ceilings, dormer windows, and the such like. So Ben, thank you ever so much for joining us, and I will now hand over to you.
Thank you very much, Gemma. I'll just share my screen over here. Hopefully that's all coming through for everybody. Yes, thank you very much. I suppose a small bit of housekeeping first. Yes, it was meant to be Anna. She's unfortunately had to whip over to the US for the rest of December. So I stepped in to deliver the presentation today. I will begin. So a little bit first on ourselves, on Hawkland. We're a Bristol-based architecture and construction company who use mostly natural materials, but appropriate materials in low carbon retrofits and new builds as well. We do a lot of straw bale new builds, trying to utilize latest developments in sustainable design and technology as well. That's the three of us directors, David, who's joining me as well today, and also Chris, who, if you come through to us for any initial inquiries, you'll get one of the three of us first. Our architecture team is myself, Anna, who is our architectural designer, Amber, who is our architecture assistant, and Michael Howlett, who we use for our straw bale projects as a technician as well. It's just some of the projects that we have worked on. But for today, how to insulate roofs, flat and sloping ceilings. So we're going to cover our retrofit approach, principles around why we do a retrofit sort of holistic whole house approach, have a look at why you might want to insulate or renovate your roof itself, looking at material choices, including sort of U values and build-ups and things, and considerations and interventions for roofs. And then we've got a few case studies of projects that we are working on currently, and ones we have recently finished. So all of these projects will be from this year, and all around upgrading roofs. So as an approach as a company, we try to work in as holistic as a way as possible, looking at the whole building. Once we get a lot of inquiries for maybe individual interventions into properties, whether that is just the upgrade of a roof or an extension on the back of a property, we'll talk to our potential clients about the whole of their house and see if that's things that they have kind of considered whilst looking to put budgets towards certain projects and certain upgrades to their property, having a look at what might be best appropriate for each property on an individual basis. We use research and evidence-based designs, standard details, material approaches, and technologies. And obviously everything is very budget dependent. So we get a lot of projects or a lot of potential projects which come to us, which might start out as one thing, but slowly evolve into something else or a different set of works, which are slightly more appropriate than what the client first thought. Sort of the reason why we look at a whole house retrofit is because of kind of moisture movement throughout properties, insulation, thermally upgrading the different sort of elements of the building, air tightness as well, and with air tightness and this insulation upgrade, ventilation, and how all of those sort of need to be looked at on a whole house, and how sometimes one intervention may make things potentially not necessarily worse, but they might not have the impact that you're looking for because other elements haven't been considered. So inappropriate interventions, they might be things like poorly installed windows, just the maintenance of properties as well being poorly maintained, outlets, ventilation, voids within properties which might stop things being as airtight and might have unregulated air changes sort of in a property, inconsistent quality throughout the different buildings, whether that's within extensions or loft conversions and things like that being put on, which might not be as appropriate for, say, period properties. Different sets of material build-ups throughout a property as well can, bring up sort of cold areas. They might make certain rooms worse once other ones have been improved. Then producing poor indoor air quality, peeling wallpaper, mold, leaks, damp, those kinds of things. So one of the first things to touch upon is materials. So we use a lot of wood fiber with our insulation projects, and whether that's sort of in walls, whether that's on in roofs or on walls or in floors, we have a look at a sustainable and natural materials as we can possibly get into our interventions. So things like wood fiber, which have sort of low VOCs, they come from sort of recycled materials, so we can consider the sort of the life cycle of a product, basically, rather than just coming in, putting something in, and then it sitting there for however long and having no thought to what then might happen to that material if an upgrade then is done in a few years' time. We like wood fiber because of its sort of benefits. So you can see from some of these, or one of these images, sort of the carbon impact of some of these insulations, the carbon impact of the extraction, how they're actually manufactured and produced, transported to sites, and sort of in their use as well. And to go down to the bottom of that image on the right, where we've got sort of wool, cork, hempcrete, straw bales. These are all the materials that we as Hawkland try to employ on our upgrade works. Looking at a little bit of comparison for materials themselves. So things like sheep's wool has a very low global warming potential, as does wood fiber, whereas PIR is quite high in its sort of use in manufacturing. And then on the other side, sort of the resource use itself, again, wood fiber is quite low in comparison to some of those more manufactured materials. For anyone who is looking to do some of this research themselves, there are lots of places that you can go to kind of get ahead of this, look at all of these different materials, and to allow you to make better sort of considered sort of more considered choices, I suppose, within the materials that you're looking to put into your buildings. So the construction material pyramid has a bunch of different materials, and it will give you a lot of good information about those, from sort of the CO2 that's produced from these sort of materials, and how they all sort of stack up against each other as well. Other benefits then of why we use wood fiber over some of those other materials: good acoustic properties. It's very robust and has a good sort of speed of application, which means that we can get sort of more work done quicker, I suppose. So if you're looking maybe not necessarily for DIY, but more for someone to come in and do this, sort of wood fiber, whether that's sort of various manufacturers, the more sort of board or batt type insulations are equivalent to, you know, PIR boards in terms of sort of their actual application and installation as well. So you don't lose time on installing natural materials. You can, and the way that we like to do sort of things, when we come in and install stuff, you might spend a little bit more money on a slightly more considered contractor who would come in and not necessarily just place insulation in between sort of rafters or joists and things like that, but actually look at the junctions between various elements. And we'll talk more on that sort of throughout. But there is a speed of application, but with that and with a more considered set of materials and details, there is a little bit of extra time spent just to get those right, you know, taping in the right places and those sorts of things. Wood fiber as well obviously has a good sort of life cycle to it as well, being sort of recyclable, as do many natural insulation materials. So a little bit on U values to touch on. These are general U values that you need to achieve for either sort of new elements, upgrading elements in existing dwellings. We won't touch much on these, but that's part of the sort of the Part L document, part of the building regulations that you would need to look at achieving. And there are some resources to be able to do that. So there's sort of free online U value calculators, which will allow you to sort of see what thermal performance you're getting. These are quite what's the word I'm looking for? They're kind of not practical necessarily. This is very sort of you know, desk based in terms of their application, because they don't take into account sort of air changes, how well things like insulation is fitted. It's just a very sort of ready set of information to say, if I use these materials within this sort of thicknesses, this is the U value I may be able to achieve with this upgrade. And we use Change Plan and Ubacus as well. Ubacus is a little more, or I'd say Change Plan is a little more user friendly. It's quite a simple process to go through to be able to pick things out, whereas this one gives us some slightly better images and build-ups in details, and shows things just a little more in detail and in depth as well. So roofs themselves, considerations and interventions. Why would you want to insulate your roof? Typically to improve its thermal performance. This might be in uninsulated attics and looking to put insulation in at the sort of the ceiling level. This might be loft conversions where you're potentially looking to bring a room within the thermal envelope of your building. It might be to bridge sort of the performance gap in certain areas. And one part of your roof might have poorly fitted insulation, as you can see from sort of the image here, where someone has tried to sort of stuff mineral wool down between the joists, and it's got stuck essentially, and hasn't insulated 2/3 of that part of the roof. And other things which come around that might be that your sort of your felt and your membrane might be towards the end of the life, especially if you've got more of the older sort of bitumen felt on your roof now, that it might need to be replaced, and it's got opportunity to then come in and insulate the sort of the roof space, and obviously it might be a potential source of large heat loss in a property. Insulating either a ceiling or the roof is usually one of the first things that that we would look at to try and help a property sort of perform, along with things like windows and doors and sort of air tightness measurements. And you can go out to design professionals. I think, as Gemma was saying at the start, there are various people who can have a look at doing sort of retrofit plans or retrofit assessments for properties as well. And that should give you a good list of interventions to be able to follow. And usually if your roof or your ceiling isn't insulated, that will be high up on that list as a relatively reasonable cost intervention to be able to do to give you a good sort of performance boost for the property. Additional considerations, not necessarily on the build-ups or the roof itself, but things you might have to consider as part of that is things like local planning policy, whether you're in conservation areas or you have a listed building, the materials that you can use and how you talk to sort of council departments on the interventions that you're looking to put in, whether you're changing sort of external materials and those kinds of things as well. Going from tiles to something slightly different, or looking to upgrade a roof sort of structurally as well, because you might want things like solar panels and those kinds of things. So changing the actual sort of structure of the roof as well, and getting the involvement of structural engineers to help through that. And one of the big ones would be ecology, so birds and bats, and whether there are any presence of those, and getting surveys done early if you're looking to insulate the spaces, to make sure that if there is any presence of bats, that you are getting the appropriate license to be able to do the work, and that it's being done at the sort of the appropriate time of year. There's also then party wall considerations as well. So any property, any neighboring property, if you're looking to, say, upgrade the structure and you're fixing into the party wall, you need to talk to your neighbor about the work that you're doing and get a party wall agreement between you. And some of that can also happen with insulation. If you're looking to do a loft, not necessarily a loft conversion, but you're looking to bring the loft within the thermal envelope of the property, the party wall will be a leaky, cold space. If you've insulated your entire roof, suddenly that's the cold point in the room. So adding insulation to that part, whilst it's not necessarily the roof, it's still part of that space, part of that thermal envelope that you're looking to improve upon. So talking to your neighbour about insulating party walls, especially in the loft space as well. And some of that might come in with other elements like acoustic improvements and things like that. And it's best usually to talk to an architect or a design professional to get advice on the other elements of that, rather than just putting some insulation up onto on a party wall. Having those other holistic considerations for a whole property sort of taken into account as well. So some interventions for the roof itself, as we sort of mentioned, either relaying insulation in the attic, so at the ceiling level, or adding insulation on top of that just to improve the performance, is quite a low cost intervention. Something a lot of people can do themselves. There are lots of companies out there as well that will do that as a sort of a service for you. But it's looking at, again, are you storing stuff up in your loft? There are considerations about putting in sort of loft stilts and boarding to make sure that if you are improving those kinds of areas, you're not compressing all of that insulation, that it's allowed to sort of do the job that it's been put up there for. Other elements maybe on the outside of the property would be sort of checking the sort of guttering and general upgrade and maintenance upgrades to the roof as well. And if you're looking more at stripping back the roof, taking all of the tiles off, putting new membranes on, that allows you to consider every part of your roof. Keeping it airtight as well with the loft hatch, and insulating and sealing a loft hatch has a big difference as well. So we're not just getting air being pulled up from sort of a landing space or wherever your loft hatch will be up into an unheated space. More deep interventions would be converting things to roofs, to warm roofs, so putting insulation in and on top of the build-ups, rather than say at the ceiling level. You're doing it at the rafter level, so bringing the entire space within the thermal envelope of the property. refitting faulty flat roofs, whether they need different falls, whether you can do that with insulations, things as well, improving air tightness layers, either through the sort of at the loft level or again up at that sort of rafter level, but as part again with any air tightness measures of looking at an air tightness and ventilation strategy throughout the whole building. And then, as we've mentioned, sort of adding solar panels or adding MVHR units, which might go up into the loft, and if there's any structural implications which might come with that as well. So looking at case studies themselves, this is where we're spending most of the time on this talk, especially with this first one, because we have a project at the moment, which is a renovation of the roof, but it has multiple different roof types. So this project has got a flat roof. It has got the roof that you can see on the left-hand side is a pitched but vaulted roof. The slight pitch you can see on the right-hand side is not vaulted. It has a ceiling into the room below. And just behind us on the right-hand side, there's also a mono-pitch vaulted roof too. So it's got a lot of different build-ups here. And we developed drawings to have a look at how we can consider each of those different roof build-ups. So whether we're upgrading a sort of a flat roof, or being able to put insulation then in between the rafters of a vaulted roof. And again, on the bottom one, putting insulation at the ceiling level as well. So this project has got multiple different roof upgrades going on with it, all of which, no, not true, not all of which, as you see from this drawing, type 1 and type 3, both being insulated from the outside. So the flat roof on this project has been entirely stripped back, and we can insulate from the outside because the client was very keen on keeping all of their ceilings because they've been newly sort of boarded and plastered, and it was work that they had done not too long ago. Whereas within the sort of the type 1, the type 2 roofs, being able to do that from the inside, so taking down boarding on the inside of those vaulted roofs rather than taking them off from the outside. So with this one, it's an existing cold roof, but there's not much insulation in there, not enough to be making an impact. So we're looking at upgrading that with more loft insulation, said from the previous slide. So that's type 1, which is down the bottom. So they've got a little bit of insulation within the existing ceiling joists, and we're looking to lay new insulation within that, but put insulation up on the top as well. That one's an inaccessible roof, which is why we're doing it. They don't have a loft hatch, which is why we're doing it from the outside for that roof. That is this kind of detail, this kind of build-up, which allows us to either just put some flexible insulation in between the rafters and potentially lay flexible insulation on the top, or to put a board on the top, something a little bit more rigid, again, to be able to allow, not in this project necessarily, but in other projects, a little bit better storage if we're using slightly more rigid materials going in. This is a build-up that comes specifically from Styco that achieves 0.14 as a thermal conductivity, as a U value to the ceiling level. This is the one where you have a slightly more solid board on the top, which allows as I say, you're putting down a sort of a deck first, so you can have access, you can store sort of things up there, rather than, say, if you were to put sort of mineral wool or sheep's wool or something like that, which doesn't want to be compressed. Sort of the wood fiber insulations allow us to work within certain depths and certain thicknesses without having that issue with compression on the insulation themselves. So this build-up would have a structural deck on top of the existing ceiling. It's always wise to check with the structural engineer as to whether your existing ceiling is suitable for storing stuff on there as well. So this is the current flat roof that we're working with. You can see pooling on it already. This has already had an intervention several years ago where they installed insulation on top of the existing roof. So there were several layers to get through when we did this, and sort of the moisture issues from just having drainage. As you can see in the bottom left of this image, the guttering and the drainage terminates onto this flat roof and then is taken inside through the building, which brings us to sort of damp staining internally, where there's been leaks or where things haven't been sealed kind of correctly around sort of drainage terminations and things. That's the drain itself. It doesn't go into anything, it just goes into a hole on this roof, and you can see on the right hand side there's the level of a layer of insulation that was just put on top of the existing roof. So this was a very hard roof to cut through. There's a layer of bitumen on the top, the insulation which came up okay, but then a tarred layer or 3 layers of bitumen then on top of a timber deck, which was on top of the existing roof. That's what it looks like. Not currently, we've moved on from that. That was a couple of weeks ago. This is it being sort of stripped back. On the right hand side, you can see that we have to consider falls. Even on a flat roof, you're always considering how moisture will move away on a roof as well. Very easy with pitches. With flat roofs, we have to look at exactly what those falls will be, things like timber furring strips, or even cut to falls level of insulation, which might be appropriate, put in to produce those falls. And this one's a little bit more difficult. It's got some clear story windows down into the living space, where we have to consider how we are either ventilating with a roof build-up or just protecting from moisture as well. So this is not necessarily a new roof build-up. We've got a slightly different build-up for this that we're employing on this roof. But this one is, again, another standard detail from a manufacturer to achieve a U value that falls within building regulations. This flat roof build-up puts insulation in between the joists, which is something we're doing. It also puts insulation on top of that. So under the new building regulations as of last June, you have to consider things like thermal bridging. So it's not sort of just adequate to insulate only between the rafters now. You have to have a look at how you are stopping cold bridging through those rafters, through those timbers, and the potential to put insulation board on the either inside or, if you have the opportunity to, the best place is on the outside of those rafters, to stop that thermal bridging as well. And this allows us, especially with a slightly more rigid insulating, sort of a sheathing insulating board, to get in sort of the ventilation layers that we would need to do. This detail has a metal roof, and I think you always have to ventilate a metal roof because of where the dew point and where moisture builds up within the roof. You have to get that moisture away, so it always has to be ventilated. We have been talking with Back to Earth, who have provided support to us, looking at things like woofy modeling to see where moisture builds up within roofs, to have a look at what they are calling a compact roof. So this is that warm roof. It's the same as the previous build-up, but without the ventilation layer. I was a little bit worried about it at first. I like a ventilation layer. It allows us to pull moisture away where needed. But with the build-up that we have here and the discussions we've had with Back to Earth, with wood fiber, we're able to push the moisture away enough that the wood fiber is able to deal with it. Critical on this detail is that we have what's called a variable air tightness membrane as well. Like a normal air tightness membrane wouldn't have been suitable for this build-up, and that's this is called a compact roof build-up. So because we've got limited working room on the flat roof on this project, we're able to come in with something that's slightly slimmer to be able to put in. But this is a slightly deeper intervention. This is a case where we're able to take the roof cover off and work from the outside back in, filling in and building back up. So we're kind of taking away but building back better, essentially, to use a government term. This then is the sort of the final roof on this project, where we will be working from the inside. This has sort of moisture issues. They aren't necessarily just because of the roof, it's to do with how moisture moves around the property. You can see lots of peeling paper on here. This is a slightly vaulted ceiling, so moisture is able to rise up towards where there is a weaker point, which is sort of the clear story windows, the junction with the roof as well. At the moment, we haven't opened this one up yet. We're just working on the outside roofs at the moment before the sort of the winter break. This is something that we'll get back to sort of in January, February kind of time, getting back in and working from the inside to insulate these. This would be an ideal build up for that vaulted ceiling. So putting insulation again within the inside of the rafters, in between the timbers, and then an insulating board internally and externally. So whether you're creating service voids internally to allow pipe work, to allow electrical runs, either in your ceilings or your walls and things, being able to insulate and then provide a service run, again, just helps with that cold bridging, just stops the timbers from being the weak point in that build-up. And again, as I say, ideally on this pitch, you'd have some insulation on the outside as well as a sheathing board. This then is, again, would have to be probably done from the outside as you're sheathing from the outside. But if your membranes are starting to go, so the bitumen felts or any breather membranes that have been sort of applied and are coming towards the end of their life, by raising the or putting some insulation on the outside, you're still coming in insulating. You don't get that disruption that you would have if you were insulating from the inside. You're taking down ceilings, especially if they're older and they haven't had any interventions done. If they're lath and plaster ceilings, is a very dirty job and is probably one best done by someone else and not yourself, because it's a horrible job. I know because I've done it myself. So sometimes going from the outside just has that less disruption to it and will allow you to obviously use the space still whilst that work is happening. But there are then things like planning considerations. You'd be raising the roof line, potentially raising the ridge as well, by building up the insulation on the outside. And what we have for our build-up is a build-up where we are only part filling the joists, basically, where we have to maintain a level of ventilation through this build-up as well. So trying to maintain 50 mil of ventilation above the insulation to pull moisture away. So it's not the same as the compact roof, which we're able to do with the deck and insulation sort of on the outside with the EPDM membrane that we're looking to put on that one. This is a tiled roof. Go back to the first image. So it's that tiled roof where we have to maintain a level of ventilation to pull up through. This is a project we worked on recently, where it was done from the inside. We came along and insulated in between the joists and have then applied a sheathing board, but the pro-passive board, which acts as the air tightness layer, just gives a bit of rigidity to the roof as well. And sometimes when you're upgrading elements, especially if you're having to potentially take out some structures, things like purlins and elements like that, how your roof maintains its structural integrity also has to be considered. So we use things like sheathing boards, all agreed with structural engineers as well. And on the right hand side, you can see where we've battened off for a service void with some conduit sort of running through as well. So the one on the left hand side is the roof just from two different angles. The first is the one where it's been insulated, and then secondly where we've applied the board and the service void. This is then the same space after we have boarded out with plasterboard. Using a service void allows us to use plasterboard. It's not a very nice material, but it is one that does a very good job. But having that service void doesn't sort of affect the moisture movement or doesn't detrimentally affect the moisture movement, let's say, and allowing that roof build-up to deal with moisture and how it works, by not penetrating through sort of the airtightness membrane too many times with plasterboard and those kinds of things. So the second case study, we are always looking at changing kind of how we not necessarily insulate, but how we're detailing, and trying to employ the best kind of ways to detail, whether that's with new materials or new technologies. This is sort of a warm roof build-up, and it's one that we are just using on a project that started today to thermally insulate and bring in a loft space into the thermal envelope so it can be used as a bedroom. And how we might, with option B, might have only just insulated on the tops or internally to the timbers to maintain things like ventilation gaps underneath tiles, but we have opted for something more like option A, where we are battening off and sort of boarding or slatting out. So we're stopping any of that new insulation that we're putting in between the joists getting up into that ventilation void, so we can maintain the ventilation pulling moisture away up through there. And again, putting a board on the inside as well on this build up to assist with that cold bridging. This is a similar build up, but as you can see with Ubacus, you get a nice detail build up through a roof. So we've been able to put in to see what kind of level of thermal performance we can achieve. So whether we've had to deepen rafters, because generally insulation which is more flexible, the insulation bats, the ones that you saw on the left hand side there, have a slightly better thermal conductivity than the boards themselves. So the more rigid boards, these ones that would be sort of on the top, only very slightly, but the more you can get in between your joists, the more flexible insulation you can get in between the joists, the better the U value will be, the better the thermal performance will be generally of that new build-up. So this one here is just sort of fully filled almost with new timbers put on the inside to frame out a little bit to insulate better within. This one doesn't have that additional layer for considering cold bridging. Here is similarly one which we did again this year, where another contractor actually built the roof itself, and we came in to do some insulating work with natural wood fiber insulation. So this is it's being fitted on the right hand side up in the flat roof, and then the image on the right hand side where we've over or underboarded with a sheathing insulation board, and then on the left with a membrane, fabric sort of membrane this time, to get our air tightness in and around that property. And then case study 3, which is probably a very scary case study, is rebuilding a roof entirely. Mentioned structural engineers several times before, invaluable on this project, where once we'd started to strip back the roof, we found, which was inaccessible on sort of first times that we were looking at it, there was a crack in the ridge, and there was a little bit of degradation in the hip on this roof, the sort of the top ridge and the top hips that you can see on that sort of towards the top of the image, which basically meant an entire new roof. What that did do was it allowed us to employ some of these techniques and different ways of insulating the roof. So it wasn't necessarily just take the boards off or have an exposed roof build-up, which this was at first. It only had, as you can see, it only had insulation at ceiling level, but they wanted to bring the ceiling or the kind of the loft space into a more and a better storage area, because all of their stuff was getting damp and moldy up in the loft. So they didn't want that. It's a small property, didn't have anywhere to store anything. The loft is the ideal place to do that. So by bringing the loft into the thermal envelope, we're able to better control the humidity, the moisture, and the thermal performance of that space. This is the new structure. It was an awkward build because of where structure had to be, single skin walls which weren't great for bearing anything on, so additional timber structure which had to go through, and this is the detail of that. So insulating in between the rafters, a little bit of insulation more for acoustic and fire performance at the ceiling level, but building up new wall plates, putting on new rafters, putting on new floor joists to make a better and improved deck. We employed 2 membranes on the outside as well. Something we haven't touched upon, won't get in too much into sort of the technical side of things on this, is that sort of wind draw from sort of insulating elements. So where you do have that ventilation gap, we're finding now that actually if insulation has been fitted sort of poorly, or in the gaps in between a timber and then the insulating layer, air can get up around there, and that is where heat will be pulled through. So almost creating a cassette, almost like a SIPS panel, as a sort of a new design to try and mitigate against some of those sort of factors as well. And with this one, we did have an insulating board on the outside, very thin insulating board on the outside as well. But because we were rebuilding a roof, we were able to maintain the ridge heights and tile line, which meant that we didn't need to go through to planning because we weren't changing any of the external kind of appearance outside of things that we were allowed to do under permitted development. So this is then the overboarded roof itself, with an air tightness layer to stop that draw, to stop that pull of the heat through the build-up. This is it then with its secondary layer of membrane on, acting as its weatherproofing, and then tiled as well as a finish. So to round out all of that, for people who are looking to do things themselves, potentially there's lots of resources that you can look at. There's the Builder's Book, which gives good sort of details or problems to avoid, at least with this, and then maybe what to do on how to actually detail between junctions. You know, it's not just insulating your roof, it's making sure that you're not getting any cold points sort of between the top of your wall and your ceiling level or the bottom of your roof, and how you might both ventilate and insulate sort of at those eaves kinds of levels. That takes you through a bunch of different the Builder's Book, bunch of different details to have a look at. There's also the sustainable renovation, which looks again at a whole house kind of renovation, details around not just roofs but sort of walls and floors and different strategies that can be employed. If you're looking to use wood fiber specifically, the Wood Fiber Insulation Academy gives more information on that, and then the retrofit pattern book itself provides more robust details as well. You have to sign up to the retrofit pattern book as well to be able to see some of those details, and they are the details themselves are much more like the details that I presented, you know, where we have this kind of drawing. So it's always worth speaking to a design professional first before you kind of embark on any of these potential upgrade works, because even if you are looking to do them yourself, it may be that you want a set of drawings or a set of information, even if it's being told which detail in the retrofit pattern book might be the most appropriate. Finding someone who can pass all of that information and understands it to be able to sort of relay it back to you is a good first step before just taking things down and starting to insulate. Thank you, everybody, for listening.
Lovely. Thanks very much, Ben. Really, really interesting. Yes, Jackie has just asked that people put their questions in the chat, please. So please do that. And I know David is keeping an eye on that. Actually, there has been a question that's come in. Sorry, I'm just jumping in. But it's because I was going to ask it as well. And it's about what do you do with dormer windows, particularly where you've got limited depth. So yeah, I'm just going to chuck that out there and then I'll stop interfering.
Dormer windows are very hard to sort of renovate, because you either have to take off from the outside and put some insulation on the outside of that dormer window, which might not be possible dependent on where the top line of your roof finish is, and how close to the tiles they get. especially if you've done something or something's been done under permitted development, because you don't want to change those levels, but you can look to put in small planning applications or household planning applications to change the heights if you have that. The other thing to do would be it depends on when it was built, because if you've had it done 2 years ago, you've probably, out of natural materials, you've probably got a good level of insulation in there between the joists, and the insulation that you might replace it with might not be any better performing. So the only other thing to do would be to come into the room itself, which with a lot of lofts, very difficult to do without affecting that head height. There are better thermally conductive materials that you could look to employ, not necessarily natural ones, but if you're looking more for that sort of natural approach, it's probably someone coming out and measuring a lot to see where you can fit that insulation, essentially, or going, great, it's making a big hole in the ceiling, saying, well, it's a mineral wool, we know that we can get a slightly better performing insulation to put in there and replace it with.
Yeah. Brilliant, thank you. Dormers, we've done a couple of dormers, or dormer windows. As Ben says, maximize the insulation as much as possible. Otherwise, probably looking at air tightness and to the condition of the window, repairing the window, especially if they're old windows and dormer windows. But very, very tricky spaces, very tight, very small, and very difficult to do. But your lower intervention would be installing like a secondary double glazing or replacing the windows, looking at the air tightness at that junction. And then upgrading the insulation where you can. But I don't know if you can see the chat now. You're sort of available. They've got a few questions coming in.
Oh, I might have to stop sharing my screen.
That's all right. No, don't worry. I'll run through it then.
I can bring up slides if they're appropriate as necessary as well.
Yeah. Flammability concerns on natural insulation. They're generally treated. They will all have fire certificates. Sometimes we can be restricted as to where we use them when we have particular fire requirements, where we have to, we just got no choice, but we have to use fireboarding and stuff like that. But the use of them when outside of that are all fine. I don't know if you've got any comments on that one, Ben, from your perspective.
I mean, again, fire strategies and things are something that we should be always talking to design professionals about. So when you look at things like party walls, whether they want sort of acoustic improvements, but fire is a big thing to consider as well. And generally, something like it again depends on the space that you have to use and the build-ups that you can do. If you can insulate with a natural material, you might look at using a fireboard or something like that, a plasterboard to protect between compartments and things, rather than say using a rock wall or a build-up in that sort of sense, which has a better sort of fire protection with that. But generally with was it permeability as well that was mentioned? It's why we look at things like service voids as well. So we're taking any of those impermeable materials like plasterboards and things sort of out of the equation by allowing that bit of ventilation up behind in a service void. That lets the natural materials kind of do what they need to, especially with membrane, appropriate membranes and things within there as well.
Yeah, I think in summary, basically all products will have testing. It'll just be a level of how good they are, how long they can last. There'll just be some scenarios where our hand is forced as what we can use. But if whatever product you're using, you should always be able to find their fire certification and performance. And we're getting a lot more materials and products out there at the moment now as well, which is brilliant. 10 years ago, there's a far fewer tested and certified products in the natural material space. Question on metal roofs and air gap. If it's laid directly on top of a felt roof, does this create an issue because of dew point? I guess you got
potentially, yes. It depends what is insulated in between the joists or the sort of the rafters. If it's sort of a bitumen felt, it's probably better to remove it. And if you're overboarding, let's say, if you're putting an insulation on the outside, you would have that opportunity. You'd have to be removing the tiles and the batten anyway. So you might refelt or remembrane, let's say, the roof and insulate at that level.
I guess if the waterproof layer is decent condition underneath the metal, that in itself should be one that fine. There will be moisture because you get quite strong heat fluctuations underneath the metal surface.
Yes.
As long as there's good air gap and a good ventilation across and the movement of air through, that should dry it out.
Yeah, with metal roofs specifically, they have to be ventilated because the metal gets so cold, basically, and that's where all of the dew point will be. So they're ventilated to be able to pull that away.
Question on attaching boards internally without puncturing membranes, causing thermal bridging. Two sort of separate points there. When fixing fiber boards or other boards on the inside of a membrane, it will puncture it. This is generally deemed as okay unless you remove that screw or fixing and then put it in a new place. So when you're sort of trying to calculate the likelihood of your air tightness performance on a passive house, you're going to be puncturing membranes as you install it. It's generally deemed that once you fix it in, you essentially create that punchy, but you plug in it with the fixing. That should be okay. No house is 100% airtight, but generally, like with the passive house standard, you don't want anything more than the equivalent of, I think, about a 10 pence piece of total air leakage throughout the entire building, which is a very small amount. So basically, if you fix it in once, you leave it there. In terms of thermal bridging, a lot of fixings that we usually get are thermally broken. So, for example, there'll be a metal screw within a plastic plug. It's slightly different if you're screwing into timber, and they'll go straight into timber. And there will technically be a thermal bridge, but there should be relatively minimal on the entire build-up. Depending on what specification you're going for, these will be calculated or not sort of included in the calculation.
And kind of on that, it's to do with sort of percentages, and there are allowable percentages that you're kind of allowed in terms of every membrane will potentially have a slightly different percentage that it can be penetrated into. And again, when you're doing sort of thermal calculations, U-value calculations and those kinds of things, we look at the percentage of, say, timber to insulation at that level, and then what we're putting on sort of over the top, the percentage of screws that might kind of go through there. So those kinds of things should be calculated as part of a U-value calculation to see what the performance of the new build-up would be, and that might make you have to reconsider, say, thicknesses and things like that as well.
If you could just possibly stop sharing your screen, Ben.
Yeah.
Now we're done. We've got a few more questions. Then it allows you to see the chat if you want to as well. Got one here from Joanna. I have air bricks just below soffit level in a 1950s bungalow. Are they there to, sorry, things in the way, are they there to ventilate the loft?
Maybe. I would probably think they're more there to ventilate the wall. If it's a cavity wall, you might have air bricks at the bottom, you might have air bricks at the top to have that flow up and through. Without having a look, I'm sorry, I can't really say much more than that, without being able to poke my head into your roof at your sort of eaves level to have a look down to see exactly what's happening. Some of that might be closed off. There might be timber wall plates on top of masonry to be able to take the roof, which would sort of stop things from being able to sort of ventilate up, which would suggest if there's air bricks at the top, there's probably air bricks at the bottom, and it's maybe a cavity to pull that through. But it could be the roof.
I've just seen further down the chat, Jones just says it's a cavity wall bungalow. So yeah, I think James might be jumping on some answers there. Question around superfall, super quilt insulation. So our opinion on when using on a pitched roof in a loft conversion to help minimize loss of height, does it affect breathability and moisture in a bad way? So this is the use of superfall or super quilt, if you've come across them, as an insulation on a pitched roof in a loft conversion.
Yep. Yeah. It's used a lot. It's high performing. We don't use it. We have removed it where we've kind of come across it. I haven't looked at, say, its permeability to know to answer right now. Kind of whether it's appropriate to use with, let's say, wood fiber build-ups and other insulations. I have seen a couple of roofs which have had that sort of superfoil put on the inside, and then a wood fiber board placed on the inside of that. But the foil blankets need a level of air around them, I believe. So they have to almost have that service void placed kind of with them as well to be able to work. So whether then that's a ventilated space or whether it's just an unventilated air gap within the build-up as well, that will affect the performance too. I think we like something more solid usually than the sort of the blankets that can go on.
Yeah, I think the thing with those is they're generally just they're not necessarily looking at insulation, they're more looking at reflection, so reflecting of heat back down rather than the actual trapping throughout sort of a low U value of material with some thermal density and a low conductivity. So there's slightly two different ways of managing heat retention, which can work. I think as a general sort of comment on any build-up that we're using, it's all about trying to detail it correctly. And that, to be honest, even taking on standard sort of manufacturing guidance and build-ups, when you come to installing that in reality, is paying very careful attention to where the airflow is, where the dew point is, where the airtight membrane is, vapor control layer, and then how that integrates with how we used to build roofs. So making sure we still do have a secondary membrane if needed under the tiles, because they never, especially using old hand-made clay double Romans, they don't sit perfectly flat, so you will get excess moisture if you're not careful. So one of our constant sort of struggles is taking what's been developed with new materials and with higher levels of standards and detailing, and for making that fit existing. And it's never straightforward, but that's probably, regardless of what you use, how you detail it is probably the biggest difference. Let's see what else we got. Aerogel has been mentioned briefly. We've never used it. I don't know if you've ever specified it. I've seen it come out quite a lot, especially around reveals or windows. I think it's something we need to try, but I don't personally have any thoughts on it, apart from the fact that inherently I'm a bit skeptical where it's used in traditional material, sort of building fabrics, just because of how it's manufactured. But yeah, I'd need to have some time playing with it before I could comment on that. But I know it has been used, and according to its sort of status sheets, it should be good.
Just to add in there, we have had some recommendations for it in conjunction with wood fibre insulation by a Lime Green in Shropshire. So they produce wood fibre boards, and they do say, particularly internal insulation, if you're getting to those areas that could create some thermal bridges, but you just can't fit in the appropriate thickness of wood fibre, it is better to put in something than nothing. And aerogel, really good solution for that. Not a cheap solution, but yeah, in those areas where you're really limited on space, or potentially tucked down next to a staircase or something like that, when you don't want to move the stairs, it can get you out of a pickle. It's not ideal. It's not the optimal solution, but it can potentially help.
Yeah, we need to look into it. It's come up in a few conversations, but we just haven't sort of played with it, because one of the hardest things for us on the delivery side is having the space to play and to experiment. And this is where a slightly different sort of conversation, but it can get a bit frustrating when you see funding go towards educational sort of institutions, but they're not including the delivery partners. So I saw some funding go towards Bath recently, and they need to be involving us on the ground, not just us or the other companies, so that we can get this joined up and double loop feedback, so we can actually play with these materials, so we can confidently specify them for clients. There's definitely a bit of a gap there between manufacturers developing new products, specification, installation and delivery, and just that little space in the middle where you can just test and play. So hopefully we'll have some more feedback on that in the future, or other materials. Let's have a look. Done that. Future-proofing on the roof structure for solar in one of your slides. What kind of work could that involve, Ben?
It very much depends if the structure is up to taking the weight of the panel system, essentially. Whether any additional sort of sheathing boards or things are needed. Lots of properties are just having solar panels put onto them, or onto the existing roofs at the moment. But again, with lots of old roofs, they've probably, if they're 100 odd years old, all of the timbers, they probably moved a lot and are in a pretty rigid, solid place. But it's always worth getting an additional opinion from an engineer on the suitability of the sort of the timber structure that's in there as to whether it could take a X kilowatt sort of solar system realistically. And it depends on what kind of system is going on there. You know, we're talking with various clients at the moment about inline solar panels, so not sort of penetrating or, you know, putting on an additional frame. They're in sort of plastic, what would be called sort of in a plastic housing almost. So that reduces the weight a little bit that's going onto the roof, but that's on a new build. Other ones where we're replacing roof tiles with these sort of solar tiles and things now. So if it's a case of just getting a solar system put onto a roof, there's lots of different options around that as well that might lead into a retrofit or an upgrade, a thermal upgrade of the roof, as well as then potentially needing a structural improvement as well.
I think it's mainly the structural considerations in terms of if you have an opportunity to just get a calculation and prepare the roof or improve the roof for future installation of solar panels, then I think that's mainly what's sort of touched on there. Most solar panels can be retrofitted appropriately, and you know, when they come to do it and install it, there's nothing really you can do during the build up, because they're all designed to be installed on existing roofs. It's more probably just making sure that the roof can take the load and adding anything whilst we have the opportunity, you know, adding any more timbers or any strengthening.
The potential for doubling up timbers, sistering them, and those kinds of things. So maybe not a whole new roof needed, but it might be some additional inserting some additional timbers in to be able to support it.
Question here from Christopher: do your insulation principles work as well in old timber frame buildings, walls and roofs where timbers are anything but uniform and parallel? I think firstly, in terms of the performance of the materials, yes, absolutely. A lot of natural materials, and you know, any modern sort of natural materials work really well with traditional build-ups. In terms of where they're anything but uniform parallel, a lot of the fiber boards themselves come in smaller boards, so they can follow the contours of undulating roofs and ceilings a lot better. If we're using, this is in a roof context, but in a wall context, material like hempcrete, we generally go with a lightweight timber frame where we cast by hand into the void, and that can fill any undulation of the old brick or stone. So that can be very appropriate for taking something that's very, not very straight, and you know, finishing with a straight face, straight edge.
Yes, there are wood fiber boards as well, which have one face of them is slightly more malleable as well. I can't remember the product, but again, another project we're working on where we're looking at putting some external wall insulation on. The client's very keen on using wood fiber for that, and us having that malleable kind of face to place against an undulating existing wall is very, very helpful to then be able to get a nice smooth flush finish externally.
Brilliant. Final question we've got at the moment from Chris: can you use wool and straw for internal retrofitting ceilings? We generally wouldn't. You can use straw and straw bales, but that generally would be part of quite either a large intervention or rebuilding a roof. So I've seen that used, but you can't leave it exposed. You've got to finish the straw. So when we use straw for our new build projects, they are plastered internally and externally. Whilst they are good when they're dense enough in terms of fire regs, I think that's just a lot. And also they're not a tested product that you can buy off the shelf. So I imagine there'll be barriers to specifying that. I don't know if in terms of use wool, I mean, if it's sheep's wool and it's a product, then yes, you could. I imagine you could just use wool that you have gathered yourself. But again, it's all about the performance certificates and the testing and the consistency. So it depends, really. I wouldn't necessarily go for straw in that context. I think that's it from the question.
I think there's one more, just the last one that's just sort of come in. From the admin, on behalf of someone else, we're hoping to upgrade our flat roof. It's about a third of our roof space. The rest is an apex roof with an insulated ceiling. When we insulate the roof, how do we fit over the eaves? We hope to insulate the walls in the future, but cannot afford it yet. So we are aware of the loss of heat through the eaves if we do a warm roof. Currently, roof felt with poor insulation between the rafters. They can't do anything from the inside, so it's all going to be built up from the outside. So that sort of the eaves, when you insulate, the eaves is it's an important junction to essentially maintain sort of the thermal envelope. So being able to kind of pull the insulation all in line kind of down and around the property, rather than having a bit of insulation here and a bit of insulation back on the walls or out on the walls and inside on the roof. Trying to maintain a line of insulation is quite important in getting that sort of thermal envelope. So again, you're mitigating against things like cold bridging. If you are looking, or maybe don't have the overhang that you need, then things like sistering timbers to create slightly deeper eaves so they can come out over the external wall insulation when that is then done. Again, it might be that you look to overboard the roof. So whether you have to go through a planning application to raise the roof line, raise the ridge potentially with a wood fibre sheathing board on the outside, so that can marry up with the external wall insulation, basically to create a completely external kind of sheathing around the building.
I think it's important to note there as well, as you're shifting the insulation layer out to the eaves and down, that you've got to shift out the air ventilated space void, because you can see issues where people insulate into the eaves, but they don't allow for the airflow. They're actually just there to go up and over. Depending where you've got that detail, whether it's on the apex or the flat, imagine it's more on the apex. Hard to answer fully without pictures, as always. I hope we cover some of that there. But George has left a nice link to a YouTube channel on flat roofing. Great.
I think that's all of us, isn't it? Oh, I've got a nice noisy plane just going overhead. That was a really interesting point, though, I think, as well, that came up just then around thinking about your future plans, not just what you're dealing with right here and now. With a lot of the decisions that you're making in retrofit, a lot of people aren't doing everything in one go. You're working either room by room or project by project as the need arises. But it is really important to be thinking 1, 2, 5 steps ahead of what you're going to be doing next, to make sure that you are getting everything lined up and one step is ready for the next, and certainly not blocking the next. So yeah, that is really interesting there, and why it is useful to get retrofit plans, get retrofit advice on your whole house, really, even if you are only starting on one part of it, so you know, and even if it's not for you, if you're planning on selling, if it's for future people that come along, you're doing things in the right order. So excellent, thank you ever so much, Ben and David. Really good session again. Had some great questions there as well, which I hope you all enjoyed. In terms of what's coming up next, we've got nothing before Christmas. We do have how to retrofit the modern home in January, and when I say modern, that is cavity wall construction, so post 1920s, 1930s, what you can do with that to reduce your energy consumption and make it more carbon neutral. And we still have Future Ready Homes is running till the end of January. We do still have a tech panel available to answer questions. So if you do have more detailed questions that have come up that haven't been covered here today or on something different, please email me with those, and we can put them through to our panel and get those responded. And we put them on our website as well, which means that everyone can share in the learning and the information. So please do that. The recording will be with everyone in a couple of days, so you can pick back up. There was a lot of content in here, so yeah, you might want to watch again, and I'll try and put some links into some of those resources that Ben mentioned towards the end as well. We got a couple of retrofit pattern book, builder's book, that kind of thing, so I'll put some links in there as well. So all that leaves me to say is happy Christmas. I hope you all have a lovely time planning your retrofits and your roof insulations. That's just what I do for my fun, so it might just be me. And we'll see you in January, hopefully.